Hey guys, so you got a worksheet due tomorrow, and I want to give you a little 10-minute video here on how to do those calculations. So, actually, I'll come back to that screen in a second. So you got this due tomorrow. Let's see, I think, wait, did I attach the same? No. Okay. So there's the back, and here's the front. All right. So on this worksheet, you're going to be using the formula MAVA equals MBVB. I got everything set up except for this here, so bear with me for a second. All right, so on the back of the reference tables, down here, right here, MAVA equals MBVB. Molarity of acid is A, H plus. Volume of acid is VA. Molarity of base is molarity of OH minus, and volume of base is VB, so MB and VB. So I'm going to show you how to use this. I'll do maybe 2-3 examples. Probably just 2 is good enough, and that should help you do this worksheet. So you're going to use that equation here each time. The only difference here is number 2, you actually have to solve for the molarity of the base, KOH, and then solve for moles. So I can kind of explain that in a little bit, I guess. And then you're using your answer for number 3 to answer these. I kind of gave you some help in the directions in the in classroom there. So that's due tomorrow, and I'll go over that. This is the setup. So in the last question here, right here, is basically, you're just kind of copying this here. And I put this on my website. So, I always have links there, like a ton of links. So anyways, I just want you to have a pretty rough idea of how to set this up. So we talked about this yesterday. I think I took a picture of this. Oh no, I took a picture of a real one. All right, so here we go. Let me get to business here. So this is an actual lab setup. This is a burette here, and that's where the base is. So the base is going to be here. So that's NaOH or KOH, for example. Down here is the acid, and this is always unknown. We don't know the concentration. So when we're using the formula MAVA equals MBVB, this is primarily what we're looking for. We don't know that. On the worksheet I gave you due tomorrow, I think sometimes I ask what is the molarity of the base. I forget what each question asks. But in general, this is the one we're looking for. So you would know the concentration of the base. So it'd be like a molarity of 1 or a molarity of 2, let's say. I don't know. So you would know this number, right? So check, we know that. You can measure the volume with the graduation marks, right? So if your meniscus is here, and then you add base to the acid down here, phenolphthalein turns light pink. That's the end point. That's when you stop. That's when you close this valve and it no longer adds base. That's the end point, right? The titration is done. So if you start here, let's say the initial volume is, let's say it says 25 milliliters right here. That meniscus is 25 milliliters. Then you add some base, and that meniscus, let's say, drops down to here. All right, and let's say, and actually I think that says 37 milliliters. So if you went from 25 down to 37, that means you added 12 milliliters, right? 12 milliliters of the base was added to the acid. So we check that, we know the volume. So we know the volume would be 12, right? So that would be 12, that would go here. The molarity of the base, MB, is whatever the problem gives you. And I'm telling you, let's say we're using KOH, 1 molar. So 1 would go in there. So the molarity of the base is 1. The volume of the base is 12. How do we know? Because in real life, in lab, you would write down the starting volume. You would open the valve. It would drip in. It would turn color. You reach the end point. Now the meniscus is down here. So this right here, all this right here, would be gone, right? In real life, the level of the liquid would drop. I'm just shading it in to kind of give you a concept here. So all of this liquid is now down here. It all dripped out and it's down here. So you just subtract 37 minus 25, and that would be 12. So that's where we get that number. Now, the volume of acid, this has to be given to you. So let's say you start with 15 milliliters, right? So the question would say you have 15 milliliters of an unknown acid, right? So we don't know molarity, question mark. We don't know the concentration, but we do know the volume is 15. So VA, check, we know that. So again, the question would give you that number. It would give you that number. You typically have to figure out the volume of the base by doing some subtraction. That's not too bad. And then the X would be here. We don't know MA, right? So if this was the problem, right? So the worksheet has problems, word problems. It's not like a diagram, but if the problem said, what is the molarity of an unknown acid? If you have 15 milliliters of that acid and you titrate that acid, that's what this is called, titration. So if you titrate this acid with 1 molar KOH, and it tells you the initial and final volumes, or it might even just give you the 12. It's really hard to kind of do all of this right now, very concisely, but if they would give you all of that information so you could figure these numbers out. Okay, the 15 and the 1 would be just given to you, probably. The 12 you would have to figure out, and now you would just solve for x. So it would be x equals 12 divided by 15, right? So it's going to be a little bit less than 1. So let me do this real quick. I just made this up on the fly here, so I didn't have the answer ready. 0.8. 0.8 capital M, moles per liter. Now, sig figs usually plays a role here. I didn't get into that, right now. But if this was 1.0, so 2 sig figs, 2 and 2, I would need 2 here. I'd have to add a 0, 0.80. All right, so that's kind of a good summary of what this is all about. I did it yesterday real quick at the end of class, so here's hopefully a little bit of help. So again, your base is up here, acid down here. You're adding the base until your phenolphthalein turns color. That's called the endpoint. This pH now should be a 7. This should be about a pH of 7. So your H plus is equal to OH minus. And if that is the case, then you can use this equation. If we reach a pH of 7 and we know the H plus is equal to OH minus, acids are equal to bases, they cancel out and you have salt water basically, some kind of salt water, then you can use this equation, MAVA equals MBVB. All right, because really what this equation means is moles of H plus equal moles of OH minus. That's really what this means. And so if that's the case, then you can use this equation, and that's the whole point of a titration. All right. So with a strong acid, strong base. AP Chem, it gets way more involved, but right now that's all we need to do. So hopefully, this is helpful. I know, sometimes when I'm done doing this, I look at the screen. There's like a million things here, but if you were following all along, hopefully you're doing all right. All right. So there's that setup. This here is a titration curve right here. I'm going to talk a little bit about this in class tomorrow. So I just wanted to show you that. It's basically when you do a titration and you add that base to the acid, your pH will go up slowly. Then it goes up very quickly. Then it flattens off again. It always looks like an S. So anyways, we'll talk more about that tomorrow. All right. So now to help you with this sheet here, I'm going to do a couple examples here. How am I doing on time? Yeah, all right. I always go over. Let me give you 2 examples. Here we go. So here's a question. Let me change this up. I'm going to go with go green today. All right. Calculate the molarity of an unknown acid with a volume of 15.0 milliliters. That's a volume. Looks like AVOL, a volume. Calculate the molarity of an unknown acid with a volume of 15 milliliters if it is titrated with, let's go with 10.5 milliliters of a 1.0 molar NaOH solution. All right, this is very wordy. What this means, And I might just give you this one example, actually, because I kind of just did one with you, and I'm giving you another one, and I went through one yesterday kind of quick. So to save some time in the video here, I'm just going to explain this one very slowly. You'll do the worksheet. We'll go over that tomorrow, and hopefully between yesterday's class, watching this, doing the homework, me going over the homework with you, you pick it up. Because at this point of the year, with limited time, we got to get moving here. All right, so if I draw over here real quick, here's a flask. All right, and then I got my burette. All right, whatever. Put the base in there. Okay, so, all right, so remember up here, that's my NaOH, 1 molar. Down here, I got my unknown acid. Here's my acid. I don't know the molarity, but I do know it's 15.0 milliliters. So I have the volume of the acid. Now, the volume of the base I gave to you right here. Right? I didn't give you an initial and then a final like I've been talking about. That's typically how it's done. But to save some time, I'm just going to give that to you, right? Because right at this point, again, for the sake of time and this year and what's going on, it's just a brief understanding of how to do this. So we're using Ma Va equals Mb Vb. All right. So molarity of acid, right? Calculate the molarity of the unknown is what we're looking for. So that's X. And that's typically what we use this for. Volume of acid, Va is 15 right here, 15.0. 15.0 equals molarity of base. I told you that right here, 1.0. So 1.0 is my molarity of the base. Now I'm keeping my 0.0s because if we're doing sig fig rules, that's important. Which we basically always do with calculations like this. All right, volume of base. So how much base does it take to reach that endpoint, right? So in this titration, you would put a couple drops of phenolphthalein in here. It would be colorless in an acid. Once the base hits it, it'll start to turn pink, flash pink. You swirl it around, and then eventually it stays light pink. So once this turns, shades to a light pink, I guess I could use the light pink, but whatever. Once this gets to be a light pink, you're done with the titration. And what does that mean? Well, how much base did it take to turn light pink to reach the endpoint, right? pH of around 7. Well, in this case, I gave it to you. They told us, I told you, it's 10.5 milliliters. So if my acid down here is 15 milliliters, and my base up here, I needed 10.5 to neutralize 15 of the acid, right? Because that's really what all this is about. I have an acid and a base, I'm mixing them. They neutralize and create some kind of salt water. That's why it's a pH of 7. Water is a pH of 7. So that's really what's happening. If I know 10.5 milliliters of a base neutralize all the acid, right? All the acid here. So again, what does this really mean? My 10.5 milliliters of OH minus, here's my OH minus. That's enough OH minus to neutralize the 15 milliliters of the H plus. So once all those cancel out, you get water. That's really what this means, right? So this concentration isn't too far off of 1. I mean, 4.5 milliliters could be significant, but it isn't like X is a concentration of 5 or a concentration of 0.05, right? It's going to be in the neighborhood of 1, kind of. I don't know. You could argue with me, I suppose, but I'm trying to get you to understand that 10.5 is needed to neutralize 15. The strength of these aren't completely different. They're not very different. So anyways, you would solve for X by doing this. 1 times 10.5 divided by 15, right? So 10.5 divided by 15.0, X equals, and we're going to keep 2 sig figs. 2 is the low number here. So 10.5 divided by 15, and I get 0.70 moles per liter. That is the answer to this question. Now, real quick, if I wanted to know moles of acid or moles of H+, I would use the molarity formula. Molarity equals moles over liters, like in that one question on that worksheet. So I would take 0.7 here. X would go for moles, and my volume of the acid is right here, 15. I'd have to convert it to liters, so it's 0.01 liters or 0.015 liters. And I would cross multiply. So if I wanted moles of acid, and this is just because that one problem asked this, that would be 0.0105 moles. So sorry, that's really messy. All right, I'm not too worried about that part. Hopefully this made some sense to you guys, and I'm going to stop because it's already long enough. I'll see you guys tomorrow.